Welcome everyone to the next in my webinar series on modern Java by example. What we're going to do today is we're going to revisit the web crawler example from a few days ago that I had originally written in Completable Futures, and we're going to redo this now, this time using RxJava. And it'll be fun because it'll give us a chance to sort of compare and contrast the different approaches that we're doing between RxJava and between the Completable Futures model. So let's go ahead and jump into this. I will go ahead and share my screen. So let's first start by talking about where you can find this example. So if you go to my live lessons repository and you go down just a little bit, you will see there's an RxJava folder here. If you click on that and you go inside, you'll see that there's several RxJava examples. We're going to be talking today about the EX4 example. And as we had talked about earlier, this is a variation of the approach we looked at the other day, which is the EX19 Java 8 example. So the EX19 example uses Completable Futures, and now, of course, we're going to go back and we're going to use RxJava instead. So let us go ahead and switch over to my IDE. So here we are in the IntelliJ project where we're going to be using RxJava this time, and this class we're about to look at will concurrently count the number of images in a recursively defined folder structure using various RxJava features. And this is a really interesting example. As with the Completable Futures version, we're going to be able to do both the version that is going to be traversing a local recursive directory structure on the computer, as well as one that could be rooted in the web. So the same code will be used in both cases. All right, so let's go take a look. Some of this stuff should look familiar. So we're going to be using a concurrent hash set that I wrote specially for this in order to be able to determine quickly and thread safely whether or not we've already traversed something earlier. So we're going to be able to see whether or not we've already traversed a page, so we don't have to revisit it more than once. And you can find the concurrent hash set implementation here in this little helper class. It's just a thin wrapper around concurrent hash map. All right, so let's go back to our program. Now things get a little bit different. So you'll see that what we had before in our image counter when we were doing Completable Futures is we had a final variable that was a completed future to the value 0. And we do something similar here where we create a M0 final observable that will just store the computed value 0. And we use that in a few places to make the code a little bit more concise. Let's go take a look at the image counter constructor. This is kind of where the magic happens or begins to happen. If you go over here, you can see that the main program just creates a new image counter and all the work gets done in that constructor. Obviously, there's other ways to do this as well. So the first thing we do is we go ahead and we grab ourselves the root URI that we're going to be using to traverse. And whether or not we traverse locally or remotely is dictated by the edit configurations of the configurations and the program arguments. So you can see here we're going to give the -w flag, which says traverse across the web. We could also do -l, which would traverse locally on the local file system. So let's stick here with looking at the website. So then what we're going to do is we're going to go ahead and call count images, starting with this root URI and the initial depth count of 1. As you'll see, we can control how deep we traverse in the recursive folder structure. So far, not a whole heck of a lot of RxJava stuff, but you'll see that what we get back from count images will be an observable, and we're going to use a blocking subscribe here, which will then basically set all the wheels in motion, and it will then block, waiting for the result to come back. And when we get the result back, we'll get back a count of the total number of images, which we print here and say the total number of images reachable from this root URI is the value that's returned from count images. So I use a blocking subscribe here just so that the program won't fall off the main function. In a real program, you'd probably use subscribe, not blocking subscribe. Okay, so let's go and look at count images. You'll see that count images is the main entry point into the program logic for counting the images asynchronously using RxJava. It takes the page URI and the depth count. And the first set of things it does here are really pretty much identical to what we did for the completable futures version we looked at a few days ago. We check to see if we've exceeded the max depth, in which case we return that M0 observable that's set to the value 0, because there's nothing to count in that case. We then go ahead and use the put-if-absent method, which is a method defined in concurrent hash set that performs the atomic check-then-act operation. And what that does, of course, is it checks to see if we've already seen this URI before. If so, we ignore it and return M0. Otherwise, we go ahead and add it, and then we'll continue the process to evaluate the contents at that image, at that URL. All right, now we get into a helper method called countImagesAsync. And this will use RxJava to asynchronously count the number of images on the current page, and then crawl the hyperlinks that are reachable from this page and count their image asynchronously as well. So we're going to do lots and lots of asynchronous, recursive, concurrent processing. We're going to get back an observable, and we're going to have a do-on-next call. Do-on-next is kind of like peek in Java 8 streams, where it doesn't really have any change in the result. It just does some side effect through the behavior that's passed, or the action that's passed to it. In this case, we're going to print how many images were found at this level in our recursive traversal. And we'll also indicate the thread ID that was used to do the computation. All right, now let's go down and look at countImagesAsync. So here's where we start getting a little bit more into using interesting RxJava stuff. You'll also notice something else I'm doing here. I'm using vars. And var is a feature that was added to Java 10, and it allows you to be able to omit the actual explicit type. And so in this particular case, just for kicks, let's go ahead and replace that with the original type so we can see what it was. So this is an observable of type document. And I'm kind of a mixed mind as to whether this is useful or not. At some level, var is kind of cool, but then it requires you to think about what you're doing. So I'll keep it with var for now, but be aware you can always toggle back and forth at your heart's desire. So what we're going to do is we're going to get the start page, and get start page, of course, is going to return an observable, and that'll be the observable for the page. So let's go down here and take a look at get start page. Here's get start page. What get start page does is it uses the observables create factory method. So this is a factory method that creates an observable to download the page. And of course, this will all be done asynchronously, as we'll see in a second. And what we do is we go ahead and take in this particular object, which you can see that it's an observable emitter. And we go ahead and get the page using the JSoup get page call, which I've cleverly wrapped in a way that works for both local files and also remote files, which are URLs. And so we're going to get that, and we're going to return it, and that's going to be the return value from this particular get start page method. So we just get one thing. So it's an observable with one entry. I'll probably refactor this code to use single when I have some more time. And then that was the only thing we did. So now we indicate that we're finished. So we say on complete, we're done. Now here's something I wanted to do. I wanted to be able to run this computation in a thread in the background. And in particular, I want to run it in a thread in the common fork join pool. So I'm going to use the compose operation, and I'm going to take the return value from apply schedulers. So let's go ahead and take a look at apply schedulers here. And we'll go down a couple of entries. And here is apply schedulers. Apply schedulers is a cool RxJava feature that's called a transformer, or returns a transformer. And you can see what it does is it goes ahead and it takes the observable and it says, please subscribe this observable and everything before and after it to run in the context of the common fork join pool. So that's going to ensure that this particular computation runs in the common fork join pool. So let's pop back up to where we did that call. I think it was right here. So what that means is we're going to go ahead and download the web page in a thread in the common fork join pool. And this is a little different from completable futures. Quite frankly, I think completable futures has a much cleaner model for doing these kinds of things. RxJava's model is a little bit verbose for my taste, but be that as it may, that's what we have to deal with. All right, so let's go ahead and go back to get start page, and whoops, let's find the get start page up here. So we had been right there. We had called get start page. So that's going to return to us an observable. Now, what's going to happen is we're going to fork the computation at this point. And that computation is going to allow us to be able to do the appropriate computation at this stage. And what we're going to see here is that we're going to go two directions. We're going to go one direction to asynchronously count the number of images on the current page, on the current HTML page. And then we're also going to fork and go another direction in order to be able to count the number of images reachable from this current page. And I'm going to do those things in parallel because they really can be done concurrently. So what we're going to do is we're going to use the page observable here. And when that completes, when that triggers, we're then going to go ahead and use the map call to get the images on the page. And we'll look at get images in page in a second. And that, of course, is also going to run in the common fork join pool, because we, once again, compose that with apply schedulers. And when that's all done, we're going to go ahead and return the size of the results of get images in page. And get images in page, essentially, will get a count of the number of images in the page. Sorry, it'll go ahead and return a collection that contains the images on the page, and then this map call down here just gets the size of that collection, which comes back as a list, of course. So let's go take a look at get images in page, and you can see here's what it does. It's really simple. All it does is it goes ahead and takes the document page, which, of course, by this point will have been downloaded, and we go ahead and we select all the image tags. So that'll give us back this collection called elements, which are going to be it'll be the names of all the image tags that are available on that page. All right, so let's pop back up here. So we take that runs concurrently, and we get the size. So when that finishes, this particular observable called images in page observable will be complete. And up here you can see, if we want to, we can go ahead and put the explicit type. It's an observable of integers. All right, so now let's go look at the more interesting wing or arm of this these fork operations. So what we're going to do now is we're going to go ahead and asynchronously figure out all the count of all the images reachable from this page. And to do that, we're going to use something called crawl links in page. And crawl links in page is going to, as you'll see in a second, return a particular value. And we're going to go ahead and use a flat map on this. And that's because we want to make sure that we don't end up with nested results. And once again, we're going to go ahead and run all this computation in the context of the common fork join pool. So let's go ahead and take a look at crawl links in page. And this is a much more interesting method. So here's crawl links in page. The crawl links in page method will use the observable from iterable factory method. Observable from iterable is going to go ahead and take the results of selecting all the hyperlinks on this page. And this is the way you do that with JSoup. You go ahead and use the select method looking for this crazy ahref syntax. And that'll return essentially a collection of, an iterable collection of hyperlinks as strings, or elements as they're shown here. So then we're going to take that and we're going to turn that into an observable. And then we're going to go ahead and we're going to apply the flat map operation again. And for each hyperlink that we are observing, we're going to go ahead and do the following code. And the reason we do it this way is so that we can get this all to run in parallel. So this is all about parallel processing. This is a particular, somewhat wacky RxJava idiom to get things to run in parallel. So for each hyperlink, we make an observable for that. And then we go ahead and make sure that this runs in its own task in the common fork join pool. And what we're going to do for each hyperlink is we're going to go ahead and count the images that are reachable from that hyperlink. And you'll notice that this call to count images is just a recursive call to this call that we had way back up here. So this is the original thing we looked at the beginning. Count images, that's the one that really sets the wheels in motion. And so now we're going to do that computation for each hyperlink that was listed on the current page. So it's going to go through and count, it's going to go through and recursively call count images, which in turn will then recursively call and do all this work. So what we're going to get back from that, as you can see here, is we're going to get back an observable with all of the integers that we've got. So we're actually going to have a whole bunch of elements, if you will, or samples, emissions, if you will, in this observable. So it's got multiple things, one for every hyperlink on the page. Now, of course, the page could have had no hyperlinks at all, in which case we'd sort of have an observable with no entries in it. And we'll come back to that in a second. So what we're going to do then is we're going to go ahead and take all of those elements and we're going to use the reduce operation. And reduce is quite a bit like reduce in Java streams, where you have a bunch of elements in the stream and you want to reduce them all together to a single element. And in this particular case, we're going to apply the sum method from the integer class to sum up all the counts from all the hyperlinks that were traversed recursively and concurrently. Now, as I mentioned before, it could very well turn out that there were no hyperlinks on the page. So if that's the case, we're going to have an empty, which is why we get back a maybe here. And so what we do in that case is we go ahead and use this default if empty method on maybe, which will either return the count if it was not empty, or it'll return 0 if it was empty. So the result of default if empty is a single integer, which is either the count or 0 if there was nothing there. And then the last thing we do here is we convert the single back into an observable, just so we can use it with our observable model. Okay, so that's basically crawl links in page, which I think is pretty cool. So let's now come back up here, and we'll see that we now will have two observables at this point. We have one observable that has the count of the number of images in the page we were looking at the moment, and that's called images in page observable. And then we have another observable, which is a count of all the images reachable from links on this page, and that's called images in links observable. And I think you probably know where we're headed with this. We're going to call this other method called combine image counts. And this takes those two observables. So let's go ahead and take a look at combine image counts. And we go down here, and here's combine image counts. You can see combine image counts takes those two observables and returns an observable. And what it does is it uses the zip method, which will take the two observables, which have the counts for number of images in the page, number of images reachable from the page, and then when both of those things complete, we will go ahead and sum them together. So ultimately, we're going to end up with a single value, which is the count of everything that's reachable from the original root URI. Okay, so that's basically what we got here. Here's get start page. We looked at that. We have get images in page, which just does the query using JSoup. We have the super cool crawl links in page method, which is really the workhorse of this whole thing, because it's the one that recursively traverses all the links that are reachable. And here's our apply schedulers method that just does the transformer. And then finally, we have a print method that conditionally prints out the results. So armed with all of that, now let's go ahead and see if this program actually works. And it better work, because I ran it earlier and it worked. So here we go. If you take a look here, you can see that what happens is we go ahead and let's move my picture out of the way. We go ahead over here and start at the initial entry point. And the initial entry point to this whole thing is this URL. So this is an images folder in my website at Vanderbilt. And so that's the starting point. And then we start traversing. And you can see here that at some point we went to the depth 3 in that particular folder structure. There's actually a level beyond what we want to go. So we say, oh, we're done. We're not going to count anything there because that was beyond our max. Then we also have URLs that occur in multiple places. The same URL occurs in multiple places in the HTML files. So again, if we've already processed something, we don't process it again. So you can see that we get another message here. And then this tells us that we found 7 images at this link, and then we go ahead and found 7 more images here, and those are images 1 and images 2. And then we go ahead and we find more images here. So those are 7 plus 7 plus, I think, 8 of them. So we end up with a total of 22 images. And you can also see how we're running in different threads. So you can see that this guy's running in thread 22, this guy's running in thread 20, and thread 20. And so that's just illustrating that we're using the common fork join pool in order to be able to kind of spread the load around and do these things in parallel. And if I'd put more debugging statements, you probably would have seen even more things happening in parallel, which would be fun to do just for kicks. So then the final result is 22 total images, which are reachable from the root directory. So that works correctly, thank goodness. And if you go back and you run the completable futures version of this on the same link, you'll get the same result, which is what you'd expect. Okay, so that was basically what I wanted to show you today. I think it's a really interesting example, but let's take a moment to kind of compare and contrast this with the completable future version. And what I really should probably do at this point is switch over and go to my trusty Emacs editor, which hopefully you can see my trusty Emacs editor. And that'll make it a little easier to do compare and contrast of these two different approaches. Let me make life a little bit easier by changing the font size here. So let's go with maybe 20, maybe too big, we'll see. I'm going to try to do this with a split screen so we can really do a apples to apples comparison of the two. So let's try that. Let's go with 18. All right, so this is the RxJava version of everything. And here's the class that really matters. And then let's go over here, and this is the completable futures version. And just for kicks, let's kind of do an apples to apples comparison between the two. All right, so starting at the top, you can see that the RxJava version is similar in that they both have a concurrent hash set, and then the completable future version uses the completed future to store the M0, whereas the observable uses the just 0. Now, one thing to note is that completable futures are actually quite a bit more like singles rather than observables. And probably in the near future, I will update this example, the EX4 example, to use singles wherever possible, because I think that's a cleaner representation of what's really going on here. There's some places where we still need to use observables, but in a lot of cases, we can use singles. So we'll kind of compare and contrast that a little bit later. Let's zip down here and take a look at the constructor, which is where everything starts running. You can see that they're very, very similar. The main difference is we have a slightly different way of handling errors. I haven't quite integrated all the error handling stuff yet into the RxJava version, but it's coming. And then the main thing that they have that's very similar is that we've got a join here. And you can see that the join kind of plays the same role that blocking subscribe does. It waits for everything to start to run. All right, let's go down a little further. So now let's take a look at count images. The first part of those are really identical. And then the part where they differ is one's going to use the completable futures mechanism, whereas the other uses the RxJava mechanism. Again, the code looks very similar idioms. We have these methods like when complete, which is just there as kind of a peek. We have methods in RxJava like do on next, which is kind of like a peek. So this code is structured very similarly. Let's go take a look down here at count images async. And you can see that count images async, in both cases, they start by getting the start page. We'll see how they differ in that regard, but they're very similar. One gets a completable future, one gets an observable. Then you'll see how they both kind of fork off, and they both go ahead and will get a future or an observable, completable future or an observable to the number of images in the current page. Again, the code is very, very similar. The main difference is, I think, it's arguably cleaner using completable futures because, as you can see, they have these methods built in, like then apply async, that does what we do with compose and subscribe on, which is just a bit more verbose. But otherwise, they're very similar. Look down here, you can see how we get the crawling all the links accessible or reachable from a given start page. Again, very similar. In the case of RxJava, we use flat map. In the case of completable futures, we use then compose async. And again, it's just ever so much more concise to use the completable futures model, but they're very similar. And then the call down here, the combined image counts, looks almost identical. All right, let's continue on. Let's go take a look at combined image counts. They are also very, very similar. In fact, the real main difference there is that in the RxJava model, we use zip, whereas with the completable futures model, we use then combine. But otherwise, they look pretty much the same. Let's go take a look at start page or get start page. You can see that in the completable futures model, it's a little more concise because we just use supply async, whereas with an RxJava, we have to use the observable create, and then we use compose. So it's a little bit more complicated, but more or less the same functionality. Get images in page, identical in both cases. Crawl links in page is really quite different, and that's interesting. So the way I implemented crawl links in page for completable futures was by using a sequential stream. So I selected all the hrefs, I converted that into a stream of hyperlinks, and then I used the map method, and I then recursively called count images. And so that'll end up basically with a stream of completable futures that are all running in the background. And then I use my super cool futures collector to combine those things all back up again into a list. So what you can see here is essentially after collect returns a completable future to the to a list, then when that is done, we go ahead and reduce it. That's what we do for the completable futures version. Let's go take a look at the RxJava version. It's a little different. What we do first is we go ahead and basically take the elements that are selected here, and we will go ahead and turn them into an iterable. And then we use that iterable with flat map. And for each of the URLs or each of the hyperlinks that we have from the iterable of hrefs on that page, we're going to go ahead and use our little trick to run things concurrently. And that uses flat map. So what we end up with here is going to be an observable that contains a bunch of integers, one for every one of the elements that we looked up recursively with count images. And then we perform a reduction, and then we turn that back into an observable. So these are very similar in a lot of ways. The actual mechanisms that they use are different. In the case of RxJava, we stick exclusively with observables, whereas with the completable futures version, we combine sequential streams with completable future features, which is pretty cool. We use the collector and so on. So they're roughly about the same degree of complexity from a source code point of view, but your mileage may vary. And then you can see that for the RxJava version, we had this method that returned the scheduler that we used for everything. Okay, so that's basically what I wanted to show. Hopefully what you came away with from there was a better understanding of how completable futures work and how RxJava works to do identical capabilities. So these programs both do exactly the same thing, just that one uses RxJava and one uses completable futures. When I have some more time, I will probably do some benchmarking to see if there's any difference in performance between the two. And of course, I will continue to improve the RxJava version to have it even more interesting and have it demonstrate different concurrency techniques, because there's different ways to do that with RxJava. And we'll take a look at that. So that's probably a topic we might cover in upcoming webinars, but I think this is probably a good thing to cover for today. So let me stop and see if there's any questions at all. Okay, so I think that wraps it up for today. We will continue doing things next week. And please take a look at the video, which I will upload here shortly as soon as we're done. And that will contain all of the analysis that we did today on comparing RxJava and completable features. So thanks, guys. I will look forward to talking to you later.